Good morning, everybody.
Good
I'm
morning.
Alex Tartas. I run the go-to-market and the sales operation at HP 3D Printing for the metal business. Delighted to be here in front of this great audience of additive manufacturing experts. Just as a starting point, I was here last year, and I remember a conference where we were stating that volatility and uncertainty were kind of the new norms. This is not a bad news, but I think the situation hasn't really improved. Geopolitical situation, economical uncertainty keep driving a little bit the business. And the world, unfortunately, which reinforced the demand and the interest for additive manufacturing in general, but we see really a high increase in demand for additive manufacturing in metal. Interestingly, and I think that was part of the multiple conversation we heard here, the request is also to transition from developing at small scale to go into production. And we see really this demand popping up. The different studies state that in 2027, I think the volume of business made in additive manufacturing metal is going to be bigger than the volume made in polymers, which is a very big signal. Not bothering you with too many details, but just setting a little bit of ground, and I will pass it over to Simon that will talk about product, as we heard before, and not use cases. HP is basically developing a production capacity solution for the additive manufacturing. We answer and we serve the traditional trend and request of additive manufacturing, like lightweighting, supply chain optimization, and the many benefit. We develop a complete end-to-end solution that is based on a process that we will briefly describe, but we are aiming and looking at delivering production solution. So repeatability, precision, tolerances, commitment on OE are part of our daily life to be able to deliver the right solution for production. We've got today customers in the range of hundreds of thousands and millions of parts. We've got customers in the range of thousands with a high mix of and diversity of parts, but always aiming at delivering the right product in the right manufacturing expectation for their customers. The solution we develop is based on binder jetting. Why are we in binder jetting? Because this is today the fastest available process for the production of metal part. I won't deep dive into too many details. We've got a booth outside. If you would like more information, we will be delighted to share more information with you. Fundamentally, I thought I had one more slide. Fundamentally, we aim to deliver value to our customers with highly productive, repeatable process in a manufacturing environment. And this is essentially what a company like HP is committed to in the additive manufacturing metal business. With that, I pass over to Simon that will share with us application and how GKN Additive, one of our contract manufacturer, is supporting the market with great solution and great parts. The floor is yours.
Thank you, Alex. Very nice introduction. And I can focus then on our part of this collaboration. And what I listened today and yesterday in the talks, when I listened to this, there's a high need for us to industrialize technology and drive this into applications. Not use cases, as I learned this morning, but products and real applications, which then drive adoption and share lighthouse projects, which inspire others to follow this as well. So that's basically the core of my presentation. That's what we do. Just to set the scene a bit, who's GKN? Maybe not everybody knows this. Like HP doesn't need to introduce themselves, but we might do. We are a business coming from the powder metallurgy industry. So we produce powder. We are one of the largest metal powder producers with 250,000 tons of metal powder, which we produce every year. And we are at the same time the largest user of these materials. We produce 10 million parts every day out of metal powder. So large-scale, automotive-driven production service provider. And then we decided a couple of years ago to move into additive manufacturing, to have this as a complementary technology to offer further products, not only into automotive, but into the global market. And that we do globally. I introduced you to this because I think it's very important to understand for the industrialization of binder jetting. Because binder jetting is the main part, for sure, is the printer getting a good green part. But then making a product out of this this initial stage of the production is very crucial and very important. And there, I think we are well set to play a strong industrialization role. And that we do with 60 printers globally, and we have access to 200 furnaces, which are required to sinter these parts to then the specifications the customer require. And that is the scene where we're coming from. And now I would like to introduce you a bit to what is necessary to drive real adoption of the technology to drive products. The one side of this, of the industrialization, is systems driven. So all our decisions we make based on data. And to capture this data, you need to connect all your printers to your internal clouds, to your systems, which drive then the order management, the performance of printers, stuff like this, quality. And all these systems, we have an infrastructure which is already set from decades of producing parts in the powder metallurgy industry. And for example, you have an ERP system which connects you to the customers. You have for sure customer drawings which you need to follow and document. Production management is very, very important, that you get the most out of your printers, get the OEE up, and implement ways to improve, always to drive for excellence. APQP is something more automotive related, but overall the GQS, which is our quality system, guarantees that the parts are tracked and are delivered in spec. The other part of the industrialization is the hardware, for sure. So the main part is the printing. You have the printers, and I'm very happy that we have this collaboration to drive the adoption of additive manufacturing. And we are lucky that HP was able to provide a reliable, well-working printer, which we implement into our shop floor. And what you see in the middle is basically our shop floor in the plant we have in Eastern Germany, in the area of Erfurt, which is a metal injection molding plant. So you see furnaces, long furnaces on your right. These are the basically generating the density of the parts. And you have injection molding machines. And now we add, instead of injection molding machines, we add 3D printers to this. And the workflow for the rest is staying basically pretty close to the workflow we have. So coming from printing, you go to green part handling, which consists of depowdering, handling of these green parts, making sure they are already in spec, and then following this, going through the plant into the furnaces. And you can see here on the right these continuous furnaces we typically use. So it's basically not a batch furnace, but a belt furnace where you move your parts through the hot zones and are much more efficient because you don't cool down the furnaces. You just move the parts through the hot zone and are much more efficient than using batch furnaces, which you need to heat up and then cool down to extract the parts again. Then last part is quality inspection. For sure, there's always product-dependent measures in place, and we need to make sure that every part leaves the site in spec. Now, I think the most interesting part of the presentation comes now. We have some use cases which are enabled by this industrialization. So the first one I would like to introduce is collaboration together with HP, Schneider Electric, and GKN. This is a filter housing, a filter which goes into a large high voltage switchboard, we integrate into the switchboard a arc breaker, because when the switchboard releases, you create an arc, and that is kind of an explosion because it ignites the plasma. And this filter, which we produce with binder jetting, stops this arc from exploding. The design benefit is size, as well as the time to market. So we were able to deliver these parts very, very fast in the development phase, and you can't produce these parts in any other way. And the only affordable and business case technology available for this one was binder jetting. So this is a very successful, which runs now in serial production for us with the customer in our plant. The next one is together with John Deere, a fuel bypass. It's a spare part, an additional part to their conventional tractors they use in cold weather environments. So there you need to heat the fuel in a bypass to generate or to make the tractor work in cold environment. And so we tested this manifold. It's you can see it here, a green part, then sintered, machined. You have some machining and the assembly, and then you deliver the final assembly to the customer as a retrofit for these environments. And that's done on a serial basis, validated to high pressure usage, and a standard product now. Last one is more like an experiment. It's not this is more a use case demonstrating the capabilities of the technology. We will not see this driving in the streets. That's for sure. But I like to show this example anyway, because it shows what the technology in general is feasible or capable of. So we developed together with Volkswagen, we developed a new alloy which goes into structural applications in cars. So what we did is we developed this dual phase steel, made it sinterable, created a bit of chemistry around this, and so it fulfilled the requirements of the customer. Then we did the printing, sintering, and heat treatment. Fed the simulation of Volkswagen with the material characteristics. They did a simulation of the design, topology optimization, and then fitted one car with the set of parts which you can see here in the middle. So these are the parts we printed. Some of them are really large, a couple of kilos heavy, and were sintered and heat treated. And then they were applied in the car, and they did the full crash test. So they took this car, which is on the bottom, and they hold it upside down and let it crash on this A-column. And it fulfilled completely crash test requirements. So it was a successful test, and that demonstrates that the technology is ready for even critical loaded applications. Yeah, with this I would like to conclude. I think we have some time for questions, and just thank you for your attention, and look forward to answering your questions together with Alex.
Yep. Just as a quick conclusion, we are. You understand that we are production ready. We are already in production. We are proud to develop an ecosystem. This ecosystem has 4 fundamental pillars: vertically integrated OEM that produce part, contract manufacturer that can produce part for OEM, research center that we are collaborating with that contribute to make this solution more innovative and more adaptive to the requirement of the industry, and powder manufacturers that we are developing relationship with to expand the scope of potential alloys that we are able to print on the HP solution. So we talked a lot about production. This is production reality. Bring us your application. We're ready to look at it, to define the value and the benefits of the solution for your application. And we've got great partners that can put it in production if you're not vertically integrated.
Thank you.
Thank you.
Thank you very much. I think we run out of time. This is the thing why we can't answer any more Q&As, but it doesn't matter at all because I think you're around. Yeah,
exactly.
And you should use the opportunity to approach these 2 guys after this excellent presentation. Thank you so much. So if you have any questions, go into direct contact, so to say, with the 2 of them. Thank you so much for your presentation. Great.